Hey guys, it's Calvin, and I just came out of school, right? So today I'll teach you about this here conduction, convection, and radiation, right? Let's talk about those, right? So let's do an experiment, right? You ever put a plastic spoon in a boiling pot of water, right? Or a metal spoon in a boiling pot of water, and as the hot goes from the tip of the spoon to the edge of the spoon, right? To where you're holding it, to the handle of the spoon, right? Why does it get hot though? That's because it's due to the second law of thermodynamics. This shows that some materials have a better heat conduction currents, right? Have a better heat absorbance material, and some materials like plastic absorb heat very little, right? Okay, well let's talk about right convection. So convection in its own definition is just hot air rising and cold air sinking, right? But the question is why? Why does the hot air rise? Why doesn't cold air rise though? Well, let me provide you an example, right? But isn't really the same example, right? So let's say you have sand, right? And you put ping pong balls on the bottom, right? And then you shake the container until the ping pong balls go up. But why is that? Why does the sand stay still and the ping pong balls go up? That's because ping pong balls are less heavy, right? And sand is much more heavier, increasingly heavy as it likes, because it's in a mass, right? A mass full of them, right? So let's say there's tons of sand, right? You can't hold a bucket of sand, they can hold a bucket of ping pong balls, right? Because a bucket of ping pong balls is less heavier than a bucket of sand, right? You know why? Because there's just little hole gaps to fill in the ping pong balls, right? Therefore, it'll reduce less mass. And while sand is smaller, it fills those air gaps in. So I feel that, right? In my definition, convection is just hot air rising and cold air sinking. So it's just basically like how a boiling pot of water, it just goes up. The hot water goes up from down to pot, right? Because you're heating that from the bottom, right? Pretend there's a fire, right? A fire. If a fire gets in contact with a pot, right? The pot will go from the bottom to the top, right? Because it's like traveling, right? If it goes from the top to the bottom, right? As you see in nature, right? Or you are cooking, right? If you're cooking, the boiling pot of water will start from the bottom and then go to the top. That's why you see those bubbles, right? That rise from the bottom to the top. You see how it all connects now? It's because the oxygen is less dense than water, right? So it rises, right? But if it's too much oxygen, right? The oxygen tends to push it down. But since oxygen is still dense, then gravity pushes it down, right? Okay, maybe I'm getting a little ahead of myself there. You'll get there, Bob. I promise. But like, for example, right? Convection is just hot air rising, and let's see what do you call it? Hot air rising and cold air sinking, right? So basically, it's just like that's what causes the the heat to radiate heat, right? So say you touch a hot asphalt concrete sidewalk, right? Or it's probably black, so it absorbs more heat, right? But do you know why black absorbs more heat than white? Let's think about this, right? I'm wearing a black, black, black jacket in the middle of winter right now. Let's see, right? And it keeps me warm, definitely. But I feel that it's not that hot enough. Why? Well, think about it. I'll give you time to think about it. So, have you thought about it? Alright, so, because it's winter, right? The air is cold. And there's not much heat going around, right? And then that increases, right? That increases because of the air around us, right? Think about it. Think about the Earth as a whole system, right? Because the air around it is just like dispersing, right? It just separated itself out, right? Because you can see that just all these directions the wind is coming from, right? You can deduce from that by you can deduce that from let's say that wind comes from all directions, right? So that's why it's like less concentrated, you know? If it's tighter, let's say you squeeze your finger, right? And you squeeze it more, right? That's what we call more concentrated because it's heavier, it's tighter, right? Why is that? Why is it more tighter when you squeeze it, right? Well, even though I don't know myself, but here's how I think about it, right? If you just, if you just like, if there's a gap in the hole, right? And you blow wind and you blow a high amount of wind within it, right? The wind will go through the gap and make a high concentration, right? It's just like in games, right? Where you just try to shoot a water gun, right? A water gun and the water just comes out, right? Even though there's a water in a tank, right? But how does this shoot so far from the water, right? That's concentration. That's what causes it to shoot out. So back to what I was talking about, right? Next time you see the sun heating the ground up, right? What do you think that infers to? So cold air sinks, right? And hot air rises. So if the hot air from the sun, right? If the sun radiates the surface, right? That's what we call radiation. On to our third one, right? So this radiation, right? It causes the sun to travel through a vacuum of space. So it requires no medium of air, no fluid. Right? So fluid, by definition, right? It's just anything that's free falling. So let's say, okay, here's my definition, right? If you can move through it, it's fluid. If you can't, it's solid. That's how you know it's a fluid, right? So, right? I believe that so you get what I mean now, right? So basically, right, radiation is it's just things you feel, right? The things you feel like heat from, right? So like for example, you light a piece of paper on fire, but you feel heat coming from it from a, let's see, an inch away, right? That's because of radiation. It moves through fluid. It moves through a fluid, right? Air, water, or any type of liquid, right? So, thing is, right? The next time you're looking at a ground, right? Or you notice the ground is hot, right? You know instantly that you know instantly that the ground is radiating heat, right? So basically, hot air rises and cold air sinks. So because hot air is less dense and cold air is more dense, so therefore it will sink and the hot air will rise. It's just a matter of which is heavy and which is not. Even in air, there's heaviness in them. That's why they rise and fall. Just like buildings, right? This building stays on the ground because it's just like its density is high and the gravity is pushing it down, so therefore that's why it's staying in place. It's not moving anywhere. That's what you call a solid. A solid has weight to it and cannot move. So the thing about like right, right. So next time you see a hot air, right, or the sun shining on the ground, touch it and tell me if it's hot or not, right? If it's hot, congratulations. You have just felt convection, conduction, and radiation all at the same time. The three trios, right? So, right, this means that, what does this mean? So this means that the sun is heating the ground through radiation. The ground is absorbing heat through conduction, and then the concrete floor, right, is radiating off heat due to convection, right? So heat rises, right, and then that causes wind. But I'll teach you this Saturday, alright? I'll teach you this Saturday about wind and why they form. So, right, wind forms from high pressure to low pressure. There's a pressure difference, just like convection and difference of densities, right? That difference of densities is what causes change. Change. You ever They ever teach you in math class about delta? Delta is the change in something, change in y over x. So that change, right? That tiny change is what causes things to move. Alright, I'll teach you this Saturday. Stay tuned, please subscribe and hit the bell and like notifications. Thank you.